Alright, our topic today is equivalent equations. And what we're talking about is two different equations that we can move from one to the other by doing one of five things. We can add the same thing to both sides. We can subtract the same thing from both sides. We can multiply both sides by anything other than 0. And we can divide both sides by anything other than 0. Or the fifth thing we can do is we can just flip the equation around. So, for example, if we started with something like 8y equals 40, what could we do to both sides? Well, let's use the example, we could divide both sides by 8. And if we did that, if we divided this side by 8, we divide this side by 8, remember, we always have to do the same thing to both sides of the equation. The left-hand side, the right-hand side, divided by the equal sign. If I divide this side by 8, 8 divided by 8 just gives me y. 40 divided by 8 gives me 5. That means that these two equations are equivalent because we've just done the same thing to both sides. How about if we did this? How about if we used 10 plus 2x equals 36? We have an equation there. Let's say that what we did with this one is we subtracted 10 from both sides. So we're going to subtract 10, and we're going to subtract 10 over here. Remember, right-hand side, left-hand side, do the same thing to both sides. We have 10 here, we take it away, then we've just got 2x left. 36, we take away 10, we've just got 26 left. Okay? That makes this and this equivalent equations. Some of you I know are thinking ahead, well that means x equals 13. If you thought that ahead, good for you. Here's another example. Let's say we had 5a minus 3 is equal to 12. And in this situation, again, equivalent equation, I could, let's say, for example, add 3 to both sides. Now this is a minus 3. Remember that the minus goes with the number that follows it. So there's a minus 3. I add 3. That cancels out. It's gone. And I'm just left with 5a is equal to 12 plus 3 is 15. And again, if you thought ahead and said a equals 3, good work, but this is what we're concerned with right now. Now, to talk more about that though, we can also do what's called solve systematically. We're interested in solving these problems systematically. It means we go step by step through a process to figure out what our answers are. Let's move these out of the way. And say that I want to solve, for example, x minus 4 equals 16. X minus 4 equals 16. Solving systematically means we're just going through a series of equivalent equations until we just get to our pronumeral is equal to something. What could we do here? Well, this is minus 4, so if I want to solve this systematically, I want to do the opposite of minus 4, which would be plus 4. So we'll do plus 4 on this side. Always do the same thing to both sides. Plus 4 on this side. What do I then have? Well, I have x. I take away 4 and I add 4 and I'm left with just x. Over here, 16 plus 4 gives me 20. Always a good idea when you're solving systematically to go back and check your answer and see if it works out. So if I do that, I put in 20 for x. 20 take away 4 is 16. Is that true? Yes, it is, and I've solved it correctly. Let's try another example. We'll do one that's a little bit harder just because it takes two steps. 2a plus 7 equals 17. It's always good, it's best practice to get rid of your addition and subtraction first before you deal with your multiplication and division. So what would we do here? We want to take that 7, because this is multiplied together, we want that 7 out of the way, so we're going to subtract 7 from this side, and we'll subtract 7 there. Again, always do the same thing to both sides. What happens? 7, we take away 7, we just have 2a left. 7, take away 7, and I'm left with 10. Now, I don't have just a. I'm working on that. I want just a all by itself. That's my goal. So what do I need to do here? Well, this is 2 times a. If it's multiplied, how do I reverse it? I reverse it by dividing. Divide and multiply reverse each other. So I have this, I divide by 2. 2 divided by 2 will just leave me with a. But remember, I have to do the same thing to both sides of my equation. I did it on the left-hand side, I have to do it on the right-hand side. So divide by 2. 10 divided by 2 gives me 5. Again, remember, I should go back and check my answer, make sure that I did it the right way. A is equal to 5, so I put in 5 for A. 2 times 5 is 10, plus 7, 17. Yes, I've done the problem right. One more example. Let's try this one. 40 minus 3x is equal to 22. Again, I wanted to do my addition and subtraction first. So, what do I need to do? Well, I want to take that 40 and put it on the other side. So what do I need to do? It's a positive 40, so I'm going to subtract 40 from both sides. Minus 40. Now if I take the 40 away, then I'm left with just minus 3x. And what do I have here? 22 take away 40, and that leaves me with minus 18. Now, I could, because there's a 3 here, I could divide by 3, 3 times x. But since it's a minus 3, I'm actually going to divide, do it in one step. I'm going to divide by minus 3. Divide by minus 3. And what happens? Minus 3 divided by minus 3 just leaves me with x. And then over here I have minus 18 divided by minus 3. A minus divided by a minus gives me a positive number. So I have minus 18 divided by minus 3 is positive 6. Now let's put it back in and see if it works. I have x is 6, so I have 3 times x, which is 6. So 3 times 6 is 18. 40, take away 18. 22, yes it is. I've done my problem right. And that is equivalent equations.